Good morning, students. This is Professor Golding again. I want to do another real quick video here on how to interpret a binary stream that's a one complement or one's complement integer. So that's what we'll do today. So again, let's go back to these two 8-bit binary streams that we have been looking at and ask ourselves, well, what if they're one's complement? What would be the value of each of these binary streams if we were told that they were one's complement? And so we can continue just like we've done in the past. We first ask ourselves, well, what would that tell me about each of these binary streams? Do they represent both positive numbers, both negative numbers, or perhaps one of each? And we'll soon see that they represent one of each. The topmost binary stream, because it has a leftmost 0, will be a positive, and the bottom stream, which has a leftmost 1, will be a negative number. So again, that's the first real important conclusion that we draw, is about whether I'm going to get a positive or negative result when I evaluate it. And we always used the leftmost bit as a sign bit. But in the case of one's complement, we're going to see that that sign bit can also be used in the evaluation. So let's continue. So first, let's evaluate the top binary stream that had a leftmost 0, 0, 1, 0, 0, 1, 1, 0, 0, and we evaluate that exactly the same way we did when we were doing signed and unsigned integers. There's no change and the value's the same. So all three of those encoding schemes actually evaluate to the same integer value whenever you have a leftmost 0. They all have a positive result and it's identical. And in this case, we see it at 76. But now things change a little bit more complicated when we look at the binary stream with that leftmost 1. We really need to have a little bit of an algorithm. And so for one's complement, the algorithm is 3 steps. 1, first you take the bits and you invert them. So that's what I've done in this step. Every bit was in the original binary stream has been inverted. And then I evaluate every one of the bits. I don't leave off the leftmost bit. That's evaluated, but it turns out that it's always a 0 in this case, because I only do this inversion when I'm beginning with a leftmost 1. Remember that. Only invert when the starting binary stream is a leftmost 1. Then when you invert, the leftmost bit is always a 0, and that evaluates to a 0, and then all of the others will evaluate to their place values. Here's 64, 0, 0, 8, 0, 2, 0. So the evaluation is 74. But then comes the final step. We add the minus sign in front of our numeric result, so our answer is always negative. So when you start with a one's complement, with a leftmost bit being a 1, you're dealing with a negative number. So never forget that minus sign. That's the most common error on tests. You invert the bits, and then you evaluate the placed values. Okay? That's it for today. Hopefully didn't go over 5 minutes. Thanks a lot for joining me.